So continuing on with our review of fractions, and again, this is something that you learned prior to grade 9, but is an important part of things we keep using over and over again in grade 9, so this is just here as a resource for you. So in the last video in the series, we looked at reducing fractions down to their lowest terms, and in this video, we're going to just review multiplying fractions. Now, we're doing multiplying before adding because, as turns out, in a lot of things in high school, when you were first learning, you learned addition and subtraction first, and then multiplication was harder than that, and then division was a little bit harder than that. It actually turns out for a lot of things that that is a little bit backwards. All of a sudden, multiplication becomes the easy thing, and addition becomes the complicated thing. So let's just start. So multiplying fractions. And this is absolutely as easy as it can be. So this is 1/2 times 3/4. And the good news is it is exactly what you want it to be. The way you multiply two numbers stacked on top of each other, fractions, is it is the top number times the top number, and the bottom number times the bottom number. So 1 times 3 is 3, and 2 times 4 is 8. That's it. So multiplication is easy. So as long as the numbers are nice, they're nice whole numbers, then you can multiply fractions, and all it is the times tables, usually from like 1 to 10 or something like that. Now, what happens is at the end, maybe you have a fraction that you need to reduce. So let's have 2/5 times 3/4. So a little bit more difficult. So again, I'll do the tops multiplied together, the bottoms multiplied together. 2/3, so this is 6. And on the bottom, this is 20. Okay? But now, as we discussed before, this is a fraction that needs to be reduced. So I need to divide this by 2. I need to divide this by 2. Okay? And this is 3/10. And again, I could convert that to 0.3 as a decimal, but I'm in high school. I like the fraction better. Now, there is a very interesting trick, which is because multiplication is so easy, that it's just tops times tops, bottoms times bottoms. That means that it does not matter whether this had the 5 on this side and the 4 on this side. It could just as well have been the 4 on this side and the 5 on that side, right? Swapping out those two bottom ones does not change the answer because all I'm doing is multiplying those two together, and all I'm doing is multiplying those two together. So it keeps the same answer. But this fraction can be reduced. This is 1/2, and this is 3/5, and then the tops, 1 times 3 is 3, and the bottom 2 times 5 is 10. So you'll notice that something happened, which is that I got the same answer both times, but when I did the divide by 2, changed. And that gives you a nice little trick. And the technical term for it is dividing out. However, the term that everybody usually calls it by is it's called canceling. And you have to be very, very careful with canceling because the rules for canceling are very, very strict, but in the questions where you're allowed to do it, it saves a huge amount of time. So you just have to be a little bit careful where it's like, I'm very, very tempted. I wish I could cancel. And if you're allowed, that's great. And if you're not allowed, it just winds up making the whole question wrong. Now, this method of switching those two is a little bit slow. So this is how it normally works when most people do it. So I will make up a question. So I will do 3/5 times 25 over 6. Okay? Now, rather than actually do the swap, so what I did before was I took the bottom two and swapped them. So this was 3 over 6 times 25 over 5. So we know this is going to turn into 1/2, and 25 divided by 5 is 5. Okay. And just a reminder, the way you do fractions multiplied by whole numbers is just remember that a 5 is really just a 5 divided by 1, because divided by 1 is one of the things that doesn't do anything. So I can still do tops and tops and bottoms and bottoms. What I actually write for the most part is, let me get rid of this, is I leave this as it is, and just in my mind know that it doesn't matter which side of the times sign you're on. All that matters is whether you're on the top or the bottom. So what I will do is I will actually take the 3 and the 6 across, and 3/6 taken together is 1/2, and 25 over 5 is 5 and 1. So this is whatever's left, which in this case is 1 times 5 and 1 times 2. And that's the answer in one step. And if I finish my work over here, 1 times 5 is 5, 2 times 1 is 2, it is the same answer. So it's something to watch out for, which is that I am allowed to reduce fractions to smaller numbers, even if they turn up sort of on opposite ends of the time sign. I'm going to do one more question just because that's a little bit confusing. And take your time with it at first, but if it's something you get into the habit of, it really just is, it's nothing more than a time saver. Because as we saw before, if you reduce before or if you reduce after, you still get the same answer. It does not change your answer. All it does is it keeps the numbers slightly smaller, and when the numbers are slightly smaller, you're doing more mental math versus calculator math, and generally just, times tables is faster than punching in on a calculator and looking for things that divide and other things. So it's a time saver. It's a very good time saver. It's a very effective time saver, but it's just a time saver. Okay, so let's see. So we're going to do 6 over 14 times 49 over 18, something like that. Okay, so I can look across the time sign. 6 and 18, those are both divisible by 6. So that will become 1/6. 18 divided by 6 is 3. That's the problem you get when you rush with these. Okay, and 14 and 49 I recognize because I remember my times tables. They are both multiples of 7, and that jumps out at me. I go, oh, multiples of 7, and that's just a hint. You get into the habit of it's like, oh, I see 2 multiples of 7 hanging out in the same question. I bet I can use that to save some time. That's all. So let's keep the colors separate so that you can follow. So both of these divide by 7. 49 divided by 7 is 7. 14 divided by 7 is 2. And now 1 times 7 is 7. And 2 times 3 is 6. So even though I started with something which was like, 49, 18, 14, those numbers were fairly large, and all just through a little bit of mental math, I got something very, very nice as an answer. So quick review, multiplying fractions. We will save addition and subtraction for a bit, do division next. So see you soon.